All right, so we talked about reflections on Tuesday. And can somebody describe to me what it means for a transformation to be a reflection? It flips. It flips over what? X or Y axis or both or some line, right? So some of the ones that you guys did in the practice would be like a horizontal line. If it's a horizontal line, what does the equation of the line look like? Is it X equals or Y equals? Y. It's kind of opposite of what you would think, right? So it's a Y equals. If it's a vertical line, it's a X equals. Good. And so if it's X equals, like say X equals 4, how do you do that? What's the process for actually doing the problem? You put that line on the graph, right? Okay. And then what? Yeah, you basically count how much you need to move the picture. What if half of them are on one side and half are on the other and the line goes through the middle? So if like A is on the left side, it would reflect to the right side. And if it were on the right side, it would reflect to the... So like half of them reflect one way, half of them reflect the other. Good. So if the line goes through the middle, that's what happens there. Okay. The line Y equals X. What does that line look like? Y equals X. You kind of did it, Daisy, with your hands. But Angel? What are you doing with your hand right now? It's like a diagonal line where the slope is what? 1. So it's just going up 1 over 1, up 1 over 1. What if it's Y equals negative X? Same slope, but the diagonal goes the opposite direction because the line's going downhill. Good, it's a negative. Okay. All right, so today we're going to talk about translations. This should be relatively quick. They should all be pretty quick for this unit. But a translation is an isometry where all points of a figure are moved the same distance in the same direction. So another word for this is a slide. So it slides. So what happens to the actual image? Does it change at all? No, it should not change at all, which means if it's a translation, your two pictures should look what? Identical, exactly the same, totally congruent. So does A appear to be a translation? Miguel?
No.
Why not?
Because it's a reflection.
Okay, it looks like a reflection because the top part right here is on the right side in the blue picture and on the left side in the red picture. So that appears to be a reflection. That would be no, and I would say looks like a reflection. Okay, what about B? Yes, B appears to be a translation, so we would just say yes. Okay? All right, so B appears to be a translation because it looks like the red picture just slid which way? Down and to the right or south? East, southeast, yeah, southeast. So down, south, and then east. So southeast. Good. Okay. We're not really going to use cardinal directions in here, but if you want to, you can. Okay? All right. It could be, I guess, if I asked you which way the blue one moved, that one moved west, but that one moved northwest.
Northwest? Yes.
This one would be north and then west. Okay. All right. So a translation is a transformation along a vector such that every segment joining a point and its image is exactly the same length. So again, that's a fancy way of saying if you connect A to A prime and B to B prime, so let's say we go back to this picture. If this is A, this is A prime. If this is B, this is B prime. That means if this right here from A to A prime is 5 inches long, how long should this be? Also 5 inches. Okay? They have to be the same length. Because if it's a translation, that means every point was moved exactly the same distance. All right? That line, that connection is called the translation vector. So remember, what's a vector? It looks like this. It looks like an arrow, right? And what does it incorporate? What do you mean by that?
I go to the finger,
That it can only keeps on going like to where the arrow like.
Okay, it keeps on going where the arrow goes. It's not just showing you a segment, it's also showing you movement. It's moving in that direction. So the vector incorporates not only like distance, remember we talked about the magnitude of a vector, so it also incorporates the movement. So the translation vector is how far it is from point A to point A prime. And what do you notice as you go from all the points along the vectors? All the vectors are what to each other? Parallel. They're parallel to each other, which means they will never what? They will never touch each other. Okay? So translation vectors will all be parallel. And again, if I put another translation vector in, because I can do it at any point. So if I pick this one right here, this point, and I pick the corresponding point here, that vector would still be what? Parallel. All right? Mine doesn't look parallel, but imagine I could draw it perfectly. Okay? It would be parallel. So any vector on this translation will be parallel to any other vector. Okay? All right, go do these 6.
Really fast.
All right, so again, just like with reflections, a lot of times it's easier to draw these when you're doing it on a coordinate plane because it gives you a frame of reference. So when you're doing a translation on the coordinate plane, there's 3 different ways you can do it. So you can do a horizontal translation along vector A, which means that in this case, which one would change? The x would change. So in a horizontal vector, in a horizontal translation, the x changes by whatever A is. So A is going to be a number. If A is 4, that means it's moving 4 to the right. If A was -6, that means it's moving to the left -6 spots. That does not mean that it moves to like the coordinate -6. That means you move 6 boxes. So if you're starting at 4, you would end up at -2. If you're starting at -2, you would end up at -8. Okay? So then a vertical translation means that which one is changing? The y, okay? So a horizontal translation, the x changed. A vertical translation, the y changed. If it's a general translation, what do you think that means? They both change. It's a diagonal, both changes. And it's going to be written like this, as an ordered pair AB. So that vector, like this, it looks like an ordered pair. If this is 3, 5, that means it's moving to the right 3, and then up 5. So north, east. All right, so up 5 to the right 3. What if it were like this? To the left 4, and then up 8. And that's for all of the coordinates. So if it's a square, then you'd be moving 4 of them. If it were a triangle, you would be moving 3. If it were a hexagon, you would be moving 6. If it were a dodecagon, you'd be moving 12. Good. Bianca.
How do you know if it affects the x or the y?
If it looks like this, if it is like 5, 0, that means it's a horizontal translation because it's only changing the x value. So this would be a horizontal. If it's a vertical, what would it look like? 0, 5. That means it wouldn't move over, it would just move up 5. Okay, good question. So then you know if it's general, if it moves both, which means diagonal. In any direction it could be.
So like, wait. So for that one, you would just move 5, but you wouldn't move anything up. Like,
So for a horizontal, you would just change your x values.
Okay.
So if it were a square, you'd move all 4 points to the right 5. And if it were vertical, like the bottom one, you would move all 4 points. Well, that one's positive 5, so all 4 points up 5. If it were general, you would move all 4 x's left 4, and then all 4 y's up 8. So you'd be going left 8. Again, don't overcomplicate this in your mind. Like, yeah, do it like what you would think you would do. So if it says like this, if that confuses you, just think like those are just the directions you're moving. Okay? All right, so translate this triangle with vertices of -2, -4, -1, -2, and C is -3, 0 along the vector 2, 4, which means describe that movement for me. Is it horizontal, vertical, or general? General. Which way is it going to move?
Right.
Right 2, up 4. Because this is the x and this is the y. So it's going to move right 2 and then up 4. So I'm going to start by plotting this at -2, -4. Then -1, -2. And then -3, 0. Okay, so there's my initial triangle. And then I'm going to move it, and I'm going to move each of the points. So I'm going to take this one, and I'm going to go right 2, and then up 4, which is going to actually take me to the origin. And then I'm going to move this one over 2, and then up 4. And then I'm going to take this one and move over 2, up 4. All right? What do you notice about the shape? It should be exactly the same. If your shape looks different, what is that telling you? You did it wrong. Okay? All right. So take these two. Hang on 1 second before you move. All right? The first coordinates, the one with the letters, are just the coordinates. The ones here with these kind of
Messed up parentheses.
yeah, the like sharp parentheses, that's your vector. So that's going to give you directions. First one x, second one y, go.
Ooh!